Here we have a SAT math problem. Okay, let's go to the question. In the figure above, ABCD is a square and AB equals to 18. If M is the midpoint of line segment AD, what is the area of triangle ABE? So in the given figure, we have to get the area of this triangle ABE over here. Okay, since ABCD is a square, all the four sides are equal in length. We have the length of one of the sides AB, that is 18. The same length we'll have for this side AD, that is 18. Since M is the midpoint of this line segment AD, then the midpoint M will divide the length of AD into two equal parts. That is, it will divide the 18 into two equal parts. Then the length of this line segment AM over here is 9. The length of this line segment MD is also 9. Okay, here at each vertex of a square we'll have right angle. So we can consider the right angle we have over here. Okay, now let's consider the right triangle ABM over here. For this right triangle ABM, we can consider this line segment AM as a base and this AB as height. So using this height and base, we'll be able to get the area of this right triangle ABM. Once I get the area of this right triangle ABM, I can get the area of this triangle AEM over here. Now, we can subtract the area of this triangle AEM from the area of the right triangle ABM over here to get the area of the required triangle, that is ABE. Okay, now we have to plan to get the area for the triangle AEM over here. For that, let me draw a vertical line through the point E over here. So here I've drawn a vertical line through the point E. Since it's a vertical line, the angle we have between this vertical line and the side BC of the square is a right angle, and also here we have a right angle. And let me say this is a point F and this is a point G. Now let's consider the interior angle of this triangle AEM over here and also the interior angle of this triangle BEC over here. So these two interior angles are equal because they are vertically opposite angles. And also we know that in a square, opposite sides are parallel and equal. So the side BC of the square and AD of the square are parallel. Then we can consider this AC as a transversal. Then what is the name of the pair of these two angles over here and here? So these two angles are called alternate interior angles and they must be equal. Now, so the two angles of this triangle are equal to the two angles of this triangle. By angle similarity postulate, the two triangles, the triangle we have over here and the triangle we have over here are similar. Okay, now let me write the similarity statement. First, let me take the vertex A in this triangle. And the corresponding vertex in the triangle over here is C, because the interior angle of vertex A over here, the interior angle of vertex C over here are equal. Now let me write the vertex C over here. Now let me take the vertex E in the smaller triangle over here. The corresponding vertex in the bigger triangle is also the same E, and the third vertex in the smaller triangle is M, and the third vertex in the bigger triangle is B. Okay, here let's consider the side AM of this smaller triangle AEM over here, because we have the length of the side AM, that is 9. Okay, now let me consider the side AM of the smaller triangle. Now let's consider the corresponding side in the bigger triangle. For that we have to consider the letters at the same position, then we get CB. Now let's get the area of the corresponding sides, that is AM over CB. We know that the length of AM is 9 and the length of the CB is 18 because it's one of the sides of the square. Let me plug in 18. Okay, here we can simplify this ratio, that is 9 goes into 9 one times and 9 goes into 18 two times. Okay, here I got the ratio of the corresponding sides of these two similar triangles. Since these two triangles are similar and the corresponding sides are in the ratio 1 over 2, so we'll have the heights of these two triangles in the same ratio 1 over 2. Okay, here the line segment EF represents the height of this triangle AEM, and this line segment EG represents the height of this triangle over here. Okay, now let me consider the height of the smaller triangle, that is EF, and the height of the bigger triangle is EG. So the heights are in the ratio 1 over 2, that is the same ratio here. Now, from the terms of the ratio over here, we'll be able to get the length of the line segment EF and EG, that is the heights of the two triangles. For that, I have to multiply the terms of the ratio over here by the same non-zero number, say x. When I multiply this 1 by x, I am getting just x. So this x represents the height of the smaller triangle, that is EF. Now to get the height of the bigger triangle EG, we have to multiply this term of the ratio by the same non-zero number x. Then I am getting 2x, that is 2 times x is 2x. Okay, here I got the height of the smaller triangle EF, that is x, and the height of the bigger triangle EG, that is 2x. Okay, now to get the length of this vertical line segment, I have to add this x and 2x. Then I'm getting 3x. So this 3x is the length of the vertical line segment I've drawn over here. This vertical line segment is parallel to the side AB of the square. So whatever length we have for the line segment AB over here, the same length we have for this vertical line segment, that is 18. So this 3x and 18, both of them represent the same stuff, that is length of this vertical line segment. So we can equate them. That is 3x equals to 18. Let's divide both sides of this equation by 3. Then we get 3 will cancel out. Then I'm getting x equals to 18 divided by 3 is 6. Okay, here I got the value of x, that is 6. Okay, now we can plug in x equals to 6 over here. When I plug in x equals to 6 over here, 2 times 6 is 12. Okay, here I got the height of the smaller triangle and bigger triangle. Let me replace the stuff in terms of x. So the height of the smaller triangle is 6 over here. The height of the bigger triangle over here is 12. Okay, now we can start finding the area of triangle ABE over here. Okay, now let me write the stuff. That is area of triangle ABE equals to, first let me write the area of this right triangle ABM over here. So that is area of triangle ABM. So from this area, I am going to subtract the area of this smaller triangle AEM, so that I'll be getting area of this triangle ABE, as I said earlier. Okay, now let me write the stuff over here. Area of triangle AEM. Okay, here to get the area of this triangle ABM, we can use the formula, that is the base times height divided by 2. Okay, here for this right triangle ABM, the base is 9 and the height is 18. So we can plug in the base 9 for B and height 18 for H and divide by 2. Let me do it over here. That is 9 times 18 divided by 2. Now to get the area of this smaller triangle AEM over here, the same formula we have to use. So that is we have to plug in this base 9 for B and height 6 for H over here. Let me do it. Then we get 9 times 6 divided by 2. Okay, here 2 goes into 2 1 times, 2 goes into 18 9 times. Here 2 goes into 2 1 times and 2 goes into 6 3 times. Here 9 times 9 is 81. Negative 9 times is 27. Okay, when I subtract 27 from 81, I am getting 54. Therefore, the area for triangle ABE is 54 square units.